AI has reached a significant point in its evolution. But despite all its advancements, there's one major problem. This issue has been holding AI back for years. It's a flaw that prevents AI from truly learning. It's called catastrophic forgetting, and it's a major barrier. Catastrophic forgetting occurs when an AI learns something new. It does so at the expense of everything it's learned before. This means every time a new task is introduced, the model forgets its previous knowledge. Imagine trying to teach a student, but every time they learn something new, they forget everything they studied previously. That's the reality for most AI systems today. No matter how advanced they become, they can't retain new information without wiping out the old. They're constantly being retrained, but they don't adapt over time. This problem has made it difficult for AI to evolve. Even when these systems are fed new data, they can't build on their previous learnings. Instead, they must start from scratch each time. This is known as catastrophic forgetting, an issue that's long plagued AI development. But this issue isn't new. It has been recognized by leading AI experts for years. Andrej Karpathy, co-founder of OpenAI, has discussed this openly. He called it one of the biggest obstacles to achieving AGI, artificial general intelligence, which is AI that can learn continuously. Karpathy believes that until we solve the issue of learning in AI, true long-term progress is out of reach. Current AI models, no matter how sophisticated, lack the adaptability that humans possess. Every time there's an update, it's like hitting the reset button on their understanding. Elon Musk has shared his thoughts on this challenge as well. He sees the chances of AI achieving AGI increasing, but we're not there yet. One of his main concerns is AI's struggle with continuous learning. Musk emphasizes that dynamic reinforcement learning is crucial for advancement. However, progress in this area has been slow so far. All the discussions about dynamic learning haven't yet materialized into reality. This is where Google steps in with a groundbreaking solution. They recently published a paper introducing a concept called nested learning. Nested learning could be a game-changer in machine learning. It aims to tackle the issue of catastrophic forgetting effectively. Instead of one massive AI brain, think of many smaller brains learning at their own pace. These smaller units collaborate to create a robust memory system. In this innovative setup, each brain learns at its own speed. Some adapt quickly, while others take their time to learn. This approach helps the system retain knowledge over time. The beauty of it is that learning doesn't erase what's already known. Each part of the system builds on the knowledge that came before. This approach is incredibly different from how AI typically works. Current models treat the training process as one singular entity. They focus on learning everything at once. This leads to the catastrophic forgetting problem. But Google's nested learning suggests that AI should learn in layers. Each layer learns at different rates. This creates a system that doesn't forget as new information is added. This layered approach forms a continuous memory loop. By controlling how often each part of the system updates, Google's model prevents the loss of previous knowledge. This method is designed to mimic the way our brains work. In our brains, different types of memories are stored and updated at different rates. Some memories, like our names or faces, stay with us for years. Others, like where we parked the car today, fade quickly. Google's nested learning aims to replicate this process. By allowing AI to store different types of information in layers, each part of the model learns and updates independently. This means the model can remember and adapt without losing past knowledge. This is a significant shift in how machine learning models have traditionally worked. Instead of forcing the model to learn everything at once, Google's approach allows for a much more natural learning process. It's about gradually building knowledge without losing any of it. This is a huge step forward in the AI space. Google's research suggests that their method is more akin to human learning. The human brain doesn't forget everything every time it learns something new. Instead of forgetting, AI adapts and rewires itself continuously. That's the goal of nested learning, learning without losing past knowledge. This research could be the breakthrough AI has been waiting for. Imagine machines learning over time, without wiping their memories clean. Google believes this could solve a major hurdle in AI development. Their approach is practical and currently being tested. They've built models using nested learning, and the results are exciting. These models are already outperforming previous systems. The new method shows improvement in long-term context reasoning. It retains knowledge better over time, adapting without resets. This could be the key to creating truly intelligent systems, systems that learn and grow without starting from scratch. So, what does this mean for AI's future? If Google's nested learning succeeds, it could change everything. It could lead to AI that learns continuously over time. This brings us closer to achieving AGI, where machines evolve like humans, but we're not there yet. This is still early research. Much testing is needed, but the potential is huge. We might be on the brink of AI that learns continuously, and that would mark a new era for technology and artificial intelligence. If Google's nested learning proves successful, it could revolutionize AI model design. This isn't just a minor tweak, it's a complete overhaul of machine learning. It tackles a long-standing issue that has plagued AI for years. Traditionally, AI models are built as singular systems, learning tasks all at once. This creates a bottleneck when the model needs to learn new information. Every retraining wipes away previous learning, like pouring a new drink into a full cup. The outcome? Catastrophic forgetting. AI forgets everything it learned when new data is introduced. This has been a major challenge for developers aiming to enhance AI. But Google's nested learning presents a potential solution. Instead of learning everything at once, it breaks tasks into smaller parts. Each part learns and updates at its own pace, creating a more efficient system. Some parts may learn quickly, while others adapt over longer periods. These layers collaborate to form a cohesive whole. This learning approach mimics how our brains function. In our brains, memory isn't a single entity. It's diverse and dynamic. We store different types of memory, updated at varying speeds. Some memories last for years, like childhood experiences. Others, like yesterday's conversation details, fade quickly. Nested learning operates in a fascinating way. Some components focus on immediate tasks, while others store long-term knowledge. Each component adapts independently, without impacting the others. This means AI can retain knowledge over time without losing past information. This is a major shift from traditional AI training methods. Typically, AI forgets previous learning when retrained on new tasks. Google's approach could revolutionize this process. It introduces a deeper, layered memory system for AI. Why is this important for AI development? To create machines that learn like humans, they must adapt continuously. Humans don't forget everything when learning something new. Our brains have neuroplasticity, allowing us to reorganize and rewire. This adaptability is something AI has been missing until now. Nested learning gives us a glimpse of AI's future potential. Imagine AI systems that learn over time, retaining what they already know. This could lead to machines that continuously improve, just like us. One key aspect of nested learning is its adaptability. Traditional AI systems are often rigid and predefined. They only update when retrained, which limits their growth. With nested learning, systems adapt at various levels. Each part learns independently, adjusting at its own pace. Different types of knowledge can be updated at different rates. Imagine a model that retains general knowledge while learning new specifics. It can enhance its core reasoning skills without losing old tasks. This could bring AI closer to artificial general intelligence, or AGI. AGI is the ability of AI to reason and adapt across various tasks. Currently, AI models are narrow, focusing on one thing at a time. But with continuous learning and adaptation, AI could become more versatile. Picture an AI that learns everything from solving puzzles to playing chess. It wouldn't forget the basics while mastering new skills. This shift is crucial for AI development. Until now, we faced the challenge of catastrophic forgetting. No matter how much data we fed it, AI struggled to retain everything. But Google's nested learning could change that. This system offers a full spectrum of memory that adapts over time. It's a more flexible approach to learning. This could unlock more human-like intelligence in AI. However, this method is still in its early stages. The research shows promise, but it's not perfect yet. The models created with nested learning demonstrate potential. Yet, there's still a long road ahead for development. Google's team is continuously refining the system. Their paper introduces the concept of a continuum memory system, or CMS. This CMS combines different levels of memory that update at varying speeds. In a typical AI model, there's short-term and long-term memory. CMS takes this further, blending the two into one smooth system. This new model allows for richer recall. Memory doesn't just stay static. It evolves and updates. It creates a continuous learning loop. Google introduced a new architecture called HOPE. HOPE is a self-modifying version of a memory-heavy architecture known as Titans. Titans were designed to manage long-term memory. They had two levels of learning, short-term and long-term. HOPE goes further by adding an unlimited number of learning levels. This means that HOPE can continually adapt how it learns. It can adjust its own learning process, creating a dynamic feedback loop that enhances itself. The results have been impressive. HOPE has outperformed traditional models on several benchmarks. For example, HOPE has lower perplexity. It also has higher accuracy and better long-context reasoning. HOPE outperforms older models like Mamba 2 and Titans, especially in tasks where fine details must be extracted from large datasets. These benchmarks are promising, but the research is still ongoing. As this research continues to develop, it's clear that Google is tackling one of AI's most significant problems. The question remains, will nested learning be the breakthrough we've been waiting for? Or is this just another step in the long journey to AGI? Only time will tell, but the future of AI is looking brighter. Google's work with nested learning is paving the way for continuous learning in AI. This could be the foundation for machines that evolve over time. Imagine AI that learns without losing previous knowledge. As research progresses, we might see AI systems that are more adaptable and intelligent. The implications of nested learning are enormous for the future of AI. If successful, it could redefine how we understand AI capabilities. AI that retains knowledge could evolve much faster than before. Picture machines that continuously adapt and improve with every experience. This is the progress AI developers have longed for. Currently, most AI models rely on static data for training. Once trained, their knowledge remains fixed and unchanging. There's no ongoing learning after the initial training phase. Today's AI models can't adapt to new data independently. They require periodic retraining, which often leads to forgetting. This is where Google's nested learning could revolutionize everything. By enhancing adaptability, AI systems can learn over time. Models won't need to start from scratch with new data. Instead, they build on existing knowledge, improving continuously. This mirrors how humans learn and retain information. When we learn something new, we don't forget everything else. We build upon our past knowledge, adjusting as we go. Our brains evolve and rewire in response to new experiences. Google's nested learning aims to replicate this human-like adaptability in AI. One of the main advantages of nested learning is its flexibility. The system allows different parts of the model to learn at different rates. This means some parts can learn quickly, while others take their time. This approach mimics how our brains store and process information. In human brains, memories are stored in layers, with some retained long-term and others fading quickly. Google's nested learning proposes a similar structure for AI. Each layer of the AI system learns independently. These layers work together to form a cohesive whole. With this method, AI doesn't sacrifice old knowledge when learning new things. Instead of retraining the entire model, specific parts update independently. This enables continuous learning without losing previously acquired knowledge. This is a significant leap forward for AI development. But how does this affect the way AI is trained? Traditionally, AI models are trained using backpropagation. In backpropagation, the model learns by adjusting its parameters based on errors. This can be problematic for long-term learning. Nested learning changes how this process works. Instead of treating each piece of data as isolated, the model recognizes patterns and relationships. This allows the model to retain more stable knowledge, even with noisy data. The ability to remember relationships could make AI more stable over time. The key to this new approach is the Continuum Memory System, or CMS. In traditional models, we only have short-term and long-term memory. CMS merges both types into a full spectrum of memory. This allows AI to store information that updates at different speeds. Some memories are refreshed in real time, while others evolve over months or years. This gives the model a more human-like recall system. It can remember things as they become more relevant over time. This adaptability preserves the richness of past experiences. This is what makes Google's nested learning unique. It's not just about having more data, it's about a dynamic learning system. Now, let's explore the technical side of this model. Google has developed a new architecture called HOPE. HOPE enhances the Titan model for better long-term memory management. While Titan could store information, it struggled with adaptability. HOPE improves on Titan by introducing multiple layers of learning. Instead of just 2 memory levels, HOPE creates infinite learning layers. This allows the system to adjust its learning continuously. It creates a feedback loop where the model constantly improves itself. This self-modifying feature is what sets HOPE apart from older models. HOPE can tweak its own learning process, which is groundbreaking. It doesn't just store knowledge, it refines how it stores knowledge. This results in a more flexible and adaptive system over time. In tests, HOPE has outperformed models like Titan's and Mamba 2. It shows better long-term context reasoning and higher accuracy. In some tests, HOPE's performance was nearly flawless. It outperformed older models, especially in tasks needing deep context understanding. HOPE's ability to find small details in large data sets is truly impressive. In the needle-in-a-haystack tests, HOPE and Titan excelled together. Both models uncovered details buried in massive text samples much faster than their predecessors. So, what does this mean for the future of AI? Google's nested learning and HOPE are pushing the boundaries of possibility. These advancements could lead to AI learning as we do. This would be a significant step toward true artificial general intelligence, AGI. But we're still not there yet. While the research is promising, it's still in its early stages. There's much more testing and refinement needed ahead. However, this is a crucial step in the right direction. AI that learns continuously, without forgetting, could transform our lives and work. Google's nested learning approach may just be the breakthrough we need. As we move forward, the future of AI is clearly evolving. Continuous learning without catastrophic forgetting could unlock many possibilities. AI systems could become more adaptable, more human-like, and more capable of solving complex, real-world problems. It's an exciting time for AI development, and we're just getting started. Looking ahead, Google's nested learning could set a new standard for AI. This innovation tackles a significant challenge in machine learning: the inability of AI systems to continually learn and adapt. The ability for AI to build upon previous knowledge without forgetting is a key feature that could unlock true AGI. Currently, most AI systems are highly specialized. They're trained for specific tasks, but their learning doesn't extend beyond that. Once an AI learns something, it's typically locked in. It can't improve upon past knowledge unless explicitly retrained. This rigidity limits its potential. Google's nested learning could change the game for AI. Imagine a system with multiple layers of memory, each learning at its own pace. This flexibility is something we've never seen before in AI. It's like giving AI a brain that evolves and adapts constantly. Current AI models are like sponges, soaking up everything but forgetting the important bits. Google's method, however, creates a structured memory system. It prioritizes knowledge, allowing continuous improvement without loss. Our brains don't forget everything when we learn something new. We build on what we know, adjusting as we go along. Google's nested learning aims to mimic this natural process in AI. The potential impact is huge across various industries. Imagine AI that continuously improves without needing retraining. These models could become more efficient and capable over time. This innovation could revolutionize healthcare, robotics, and autonomous vehicles. AI could adapt to new data and experiences, becoming more reliable. It wouldn't just be limited to narrow tasks anymore. AI could learn across different domains, making connections like never before. But, as with any breakthrough in AI, challenges still lie ahead. The research is still in its early stages, and widespread adoption of nested learning is yet to come. There are many questions that remain unanswered, and potential hurdles that could slow progress. For instance, how will the system manage large datasets and noisy information? What computational resources will be necessary for continuous learning? These are critical questions that need addressing. Google's work has set the stage for a new era in AI. The future possibilities are truly exciting. Introducing Hope, Google's innovative self-modifying model. Hope advances nested learning by enabling continuous self-improvement. It adapts its learning based on acquired knowledge, creating a dynamic feedback loop. This allows for faster and more efficient learning processes. Hope's performance surpasses traditional models like Titans and Mamba 2. It demonstrates significant improvements in long-term context reasoning and accuracy. In needle-in-a-haystack tests, it identifies small details quicker than older models. Hope symbolizes the future of AI, capable of continuous learning and adaptation. It evolves in real time, similar to how our brains update their understanding. Hope's success in benchmarks indicates a shift toward more intelligent and adaptable AI systems. As we approach the era of artificial general intelligence, models like Hope are paving the way for what's possible. They show us how AI can evolve beyond just learning from data. The secret to AGI might be in continuous learning, where machines enhance their own learning over time. Imagine AI that adapts, evolves, and grows in intelligence. We could witness systems developing new skills and improving reasoning. AI could retain knowledge without ever forgetting what it learned. This evolution could change how we interact with technology. As Google advances its research, more companies might adopt these innovative techniques. Nested learning could redefine AI development standards, enabling continuous improvement and human-like reasoning. This shift could lead to smarter, adaptable AI tackling real-world challenges. But we still have hurdles to overcome. Despite the challenges, Google's progress is promising. The future of AI shines brighter than ever before. Nested learning might be the breakthrough we need. In summary, nested learning is a thrilling advancement. It tackles a major AI issue: catastrophic forgetting. By allowing continuous learning without loss of knowledge, Google's research opens doors to more intelligent systems. As AI evolves, the possibilities for its applications are limitless.